Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Suneel Kumar Bandaru. Students, in this basic electronics through topic wise MCQ series, we have completed 4 sessions. This is the fifth one. If you want previous, you can watch in this YouTube channel by clicking on playlist. Okay. So let me check up to which we have completed. All these questions completed now. Yes. Now coming to rectifier based questions. Here the number of diodes used in center tap full wave rectifier. Coming to this number of diodes, very important question and very easy question. In case of half wave rectifier, in case of full wave, center tap and bridge rectifier. Okay, so in half wave rectifier, just one only we use, center tap 2, bridge rectifier 4 diodes we are using. So center tap full wave they are asking, that is 2 diodes. So the answer is option B. Okay. So the answer is option B. Coming to the next question, guys. The maximum value of voltage Vm is equal to 10 volts. Then RMS value of half wave rectifier output. So coming to RMS values of half wave rectified output. Okay. So first of all, VRMS for half wave. In case of full wave, bridge center tap and bridge rectifier. Okay, so in case of half wave rectifier, what is the RMS value, guys? RMS is equal to Vm by 2. In case of center tap and bridge rectifier, both are same, Vm by root 2. Here also Vm by root. So they are asking for half wave rectifier, that is Vm by 2, that is 10 by 2, that is equal to. So the answer is option B. Okay, so answer is option B. Coming to the next question, guys. If they are asking average values, we average are also VDC. VDC. For this half wave rectifier, Vm by 5 only. Here you can consider center tap 2 Vm by 5. It is also 2 Vm by. So RMS value is Vm by 2. Average value is Vm by 5. Okay. Coming to the next question. Form factor of half wave rectifier output. Form factor. Yeah. Okay. We know very well the peak factor and form factor definitions. Peak factor. PF. Peak factor is nothing but, for example, if you can consider a wave. Okay. So this is the maximum value or peak value. After that, 0.63% is average value. Okay, and 0.707 is RMS value. Okay, so just wait, I want to in full. You can consider a wave. Okay, this is the maximum value or peak value. Okay, and this is the RMS value. Okay, and 0.63 times 63% average. Okay, average value. So this is the maximum value, that is like 100%. VRMS is nothing but 0.707, that is 70.7. This is 0.63, that is 63%. Okay, so here peak factor. Peak factor as the name itself, it is associated with the peak value. That is, what are the peak values here? VP, VRMS are the peak values now. So VP by VRMS. The same way, form factor below 2 are nothing but VRMS by V average. So like that you can simply remember V average. Okay. So in this case, if you want to get form factor VRMS for half wave rectifier, full wave rectifier, center tap, bridge, you can calculate half wave rectifier RMS value VM by 2, average value VM by pi. So that is VM cancel pi by 2, that is 3.14 by 2 means 1.57. So 1.57. Okay. So the answer is 1.57. Coming to the center tap. Center tap, same. If you can calculate VRMS and V average, then you will get 1.21. Okay, here also you will get 1.21. Same values for center tap and bridge. Okay, so if you don't want to remember, you can calculate. VRMS is nothing but VM by root 2 and V average is nothing but 2 VM by pi. Then you will get 1.21, 1.21. And peak factor. So peak factor is nothing but peak value by RMS value. Okay, peak factor is nothing but maximum value or peak value by RMS value. Okay, and what about the peak factor for this? Maximum value is VM. VRMS is nothing but VM by 2. That is nothing but peak factor is 2. So highest peak factor we have for this half wave rectifier output. Okay, in case of center tap, maximum value by VM by root 2, that is equal to root 2. You will get root 2. Okay, coming to the next question. Ripple factor of half wave rectifier output is dash. Ripple factor is denoted by gamma, that is root of form factor square minus 1. Okay, root of form factor square minus 1. Form factor is 1.57 now. Root 1.57 whole square minus 1, then you will get the ripple factor is nothing but 1.21. Okay, so this is for half wave, and in case of full wave, center tap and bridge is 0.48, 0.4. Okay, so here 1.21, so the answer is option. Coming to the next question, the maximum efficiency of half wave rectifier output is dash. The maximum efficiency of half wave rectifier output is dash. So the maximum efficiency of half wave rectifier output is just 40.6%. Okay. In case of full wave rectifier, it is double, that is 81.2%. Just wait, I want to give a table. From the table, you can get all these terms easily. Just wait a little bit. Okay, so all of you note down it. Very important, guys. If you know also, try to note down the form of table. Okay, let us take some particulars. Is in case of half wave rectifier, here full wave rectifier. So in full wave rectifier, center tap, bridge. First of all, number of diodes. We know how many in half wave? 1. Center tap, 2. Bridge rectifier, 4. Okay, and VDC or average value. So for average value is VM by pi. Here 2 VM by pi. Here 2 Vm by 5. Okay, and RMS value Vm by 2. Here Vm by root 2. Vm by root 2 by 2. Okay. Now coming to form factor. Form factor for this 1.57, for this 1.11, 1.11. Okay. And ripple factor. Just now we have discussed 1.21, 0.48, 0.48. Okay, 0.48. Now maximum efficiency. 0.48, sorry, 406, that means 40.6. Just wait. 40.6%, 81.2%, 81.2%. Okay, and peak inverse voltage. This is the very important. After rectifier input is just Vm. For center tap, its requirement is 2 Vm. So if you want to use 2 Vm of PIV, then cost of the diode is higher. That is the disadvantage in case of CD. PIV requirement is higher in center tap. That is a disadvantage of CT over than the bridge rectifier. Okay, 2 Vm, here Vm 1. Okay, and ripple frequency. Here F, here 2F, here 2F. Okay, and coming to transformer utilization factor, very important, 0.287, 0.693, 0.812. Okay, 0.812. I think these are visible now. No. Okay, so note down. Okay, so that means the main differences are, this is the one of the difference between CD and bridge, and one more thing is PIV rating, and one more thing is transformer utilization factor. Okay, so these are the main differences. Note down and just wait a little bit after that. Okay, completed. Coming to the next question. The transformer utilization factor of center tap full wave rectifier. We have already discussed in half wave it is 0.287, center tap 0.693, and bridge rectifier 0.812. Na? So here center tap full wave rectifier 0.693. So the answer is option D. Okay, coming to the next question. The PIV in center tap full wave rectifier. I have already given PIV for center tap. It is requirement is higher, that is nearly 2 Vm. So the answer is option B. Coming to the next one, a bridge rectifier uses 9 volts AC input voltage. The diodes are ideal, then DC output voltage. Bridge rectifier DC output VDC is equal to 2 Vm by 5. Okay, a bridge rectifier uses 9 volts AC input voltage. So whatever the input voltage, that is RMS value, that is 9 volts. So if you want maximum value is equal to root 2 into RMS. So that is 2 into root 2 into RMS. That is nothing but 9 volts by 3.14. Okay. So then approximate value 2 into 1.414 into 9 by 3.14. 18. Then what is the value? Come on, try to calculate. approximately 8.1 volt you will get. Let me check. 8.10. Yes, correct answer. So the answer is option B. Okay. So the answer is option B. Coming to the next question. The following which is heavily doped diode? Which is heavily doped diode? Heavily doped diodes are nothing but tunnel diode and also GNR diode. Here tunnel diode given. We have to go with the tunnel diode. Tunnel diode is very heavily doped diode. Okay. After that, GNR. Okay, and PN diode is lightly doped diode. Here doping concentration 1 is to 10 power 3. Here 1 is to 10 power 5. Here 1 is to 10 power 12 or 10 power 13, like that. Okay. So here tunnel diode is there. Because of this heavily doped, there is a tunneling will be done, which diode produces negative resistance region. Very important question. Negative resistance region, that means tunnel diode produces the negative resistance region. What is this negative resistance region? As voltage increases, the current decreases, then you can say that is the negative resistance. Okay, so in case of tunneling diode, as you can consider forward voltage, forward current. Here for low values of the voltage, as voltage increases, current also increases proportionality up to Vp. Okay, so that corresponding current is Ip. After that, if you further increase the voltage, then current will be decreases and to up to a certain limit. That is, that corresponding voltage is valley voltage and the corresponding current is valley current. Okay, valley current. And after that, if you further increase the voltage, then it will be increases again. So that means it will be act in three regions. For low voltage, this is ohmic region. For Vp to Vb, it is negative resistance region. Why negative resistance? As voltage increases, current is decreasing. So that's why it is negative resistance region. And this is the enlarged region. Enlarged region. Okay, enlarged region. So you can note down the points. For low values of the voltage from 0 to A, it is as voltage increases, current also increases. Okay, so this is called as ohmic region. And for more than Vp, that is Vp to Vb, as voltage increases, current will be decreases. So this is called as negative resistance region. In this negative resistance region, it will be act as relaxation oscillator. So oscillator which can produce the AC. Okay, that means here also what is happening? Negative resistance. Resistance is negative means instead of absorbing, it is delivering. Instead of absorbing, it is delivering. Okay, so it can be act as the relaxation oscillator. That is a very important feature of this tunnel diode. Okay. Which of the following diode is act as relaxation oscillator? Just now I have given relaxation oscillator tunnel diode. Okay. A reverse bias tunnel diode act as dash. In case of reverse bias, it is as voltage increases in negative terms, current also increases in the same manner. So in reverse bias, it will be just act as the resistor. In reverse bias are low values of the voltage. Both case reverse is act as the resistor. Okay. And we will discuss the remaining questions in the next session. Okay. And students, if you have not subscribed this channel, please click on subscribe button and also share this information to all your friends and so. Okay, so then only I can take more sessions, and these sessions are very much useful for your competitive examination. Okay, Very rarely you will get topic wise MCQ series. Okay, thank you so much guys, take care, bye.